welcome to the Deep Dive, where we cut through the noise and get straight to the knowledge. Okay, so the promise of large language models, it's genuinely incredible, right? But actually building robust, production-grade applications with them, that often feels like you're navigating a maze. Just calling an API, well, it's never really enough. There's some significant engineering hurdles you got to clear. Things like managing context, orchestrating like multiple LLM calls, grounding models in your private data so they don't just hallucinate, maintaining conversation state, turn after turn, debugging these really obscure errors. None of this stuff is trivial. And that's really the chasm that LangChain aims to bridge. It's exactly why we're diving into LangChain today. It's this really ingenious open source framework, and it's specifically designed to tackle those exact challenges. It gives you the structured tooling, the standardized interfaces that you need to actually orchestrate complex LLM applications. Doesn't matter if you're dreaming of sophisticated chatbots or nuanced Q&A systems, maybe even autonomous agents. It's about turning that raw LLM power into something genuinely useful and, maybe most importantly, reliable in the real world.
Exactly. And our mission really in this deep dive is to unpack how LangChain streamlines that whole development process. We're going to take you from, let's say, the initial spark of an idea through all the complexities of prototyping, and then all the way to actually deploying it at scale. By the end, you should have a really crystal clear understanding of LangChain's core components, how they fit together, and crucially, how they empower you to navigate this rapidly evolving field.
Okay, so let's unpack this then. When we talk about LangChain, it's really important to get that it's not just like one single library, right? It's actually more of a comprehensive, really modular ecosystem. And that modularity, that ability to kind of pick and choose, swap components out, that seems like a core strength because it's designed to support the entire life cycle of an LLM app. Sounds like a big promise, though. How does that ecosystem actually break down?
Yeah, it's a very thoughtfully structured toolkit. So at the very foundation, you've got langchain-core. Think of it as the bedrock. It provides all the base abstractions and really critically the LangChain expression language, or LCEL. We'll definitely dig into that more.
Yeah, CDL.
Then you have langchain-community and all the specific partner packages. This is where you find this huge collection of integrations. Think LLM providers, vector stores, databases, APIs, pretty much any external tool you can imagine. And this makes it incredibly easy to swap components. Maybe your needs change or you prefer a different provider. You don't have to rewrite your core logic.
Okay, so it's plug and play almost.
Very much. And building on top of that, the main LangChain library itself holds the higher level stuff. Abstractions like chains, agents, retrieval strategies. And then there's LangGraph. Now, this is where things get really interesting for complex stateful applications. Its checkpointing feature, in particular, is a true game changer for persistence, for memory.
Checkpointing, how does that work?
Think about it. You could have a sophisticated agent. Maybe it's in a multi-turn chat, doing actions, calling APIs. Now, if that process crashes, or maybe the user just drops off and comes back later, traditionally, all that state, all that context is just gone.
Right, super frustrating.
Yeah. Checkpointing means that entire history, even the agent's internal reasoning path, gets automatically saved. And it can be instantly restored. It's how you build truly fault-tolerant, long-running conversational experiences. Something that was, frankly, incredibly painful to manage manually before LangGraph.
Wow, so no more building custom session management from scratch or like worrying about losing a whole complex reasoning chain if a connection hiccups. That's a huge pain point solved right there.
Precisely. And then if you think about the broader development picture, LangSmith is just indispensable, absolutely crucial. It's the platform for observability and evaluation, debugging, testing, monitoring from your first prototype right into production. Honestly, you simply cannot build robust LLM applications without something like LangSmith.
Okay, observability. Makes sense.
And then finally, once you've actually built something cool, LangServe is the deployment library. It makes it surprisingly simple to turn your chains, or even your LangGraph graphs, into production-ready REST APIs.
Okay, so this integrated suite really does guide you through every stage, from that initial idea through the messy prototyping all the way to a scalable, monitored deployment in production. It feels like LangChain has a very mature take on the whole machine learning operations, the MLOps lifecycle. Now, you mentioned LCEL earlier, LangChain Expression Language. Let's talk about that core philosophy, thinking in chains. You said it's the modern declarative way to build with LangChain. How does that contrast with, say, older ways of coding these things?
It uses this concise syntax, right? Mainly the pipe operator. Looks almost deceptively simple. It does look simple, yeah.
Hmm.
But that's the beauty. Nearly every core LangChain component implements what's called the runnable interface. And what that means is they can all be seamlessly chained together using that pipe operator. You can literally write code that says, take this prompt, pipe it to this model, then pipe the model's output to this output parser. It's incredibly intuitive. Reads almost like a data flow diagram, you know?
Okay, so the pipes. It sounds a bit like Unix pipes, maybe, for data flow. But you hinted it's more than just clean syntax. What's the real superpower LCEL brings, especially for production?
That's a great question. Because this declarative approach, that's LCL's true superpower. See, with traditional, more procedural code, you'd be the one manually juggling threads, async await stuff, complex callbacks just to get parallel execution or efficient streaming.
Yeah, that sounds brittle.
It often is, and hard to debug. LCEL abstracts all that complexity away. You just define the flow of your logic using the pipes. LangChain then automatically optimizes it under the hood. It handles things like parallel execution of independent steps or streaming responses back as they're generated automatically.
So it figures out the optimal way to run.
Exactly. It frees you up to focus on the logic of your application, not the how the low-level plumbing needed for scaling and responsiveness. It's definitely a move towards more robust, maintainable, and optimizable declarative systems. It's a trend you see across modern software engineering, really.
That makes so much sense. I can immediately see how that would save hours, probably days,
Yeah.
debugging performance bottlenecks. All right, so we've got the core philosophy. Now let's guide everyone through the essential components, the building blocks of a LangChain app. Let's sort of dissect the machine, understand the critical parts and how they click together.
Okay, first up, models. Now, LangChain doesn't provide the actual LLMs, right? But it gives you these standardized interfaces to talk to tons of different providers, OpenAI, Anthropic, Cohere, open source models via Hugging Face, you name it. The main type you'll use now are chat models. They're the modern standard. They take structured messages in, output messages back. Perfect for conversational AI.
A message in, message out. Got it.
Then you have embedding models. These are a bit different, more specialized. They turn text into numerical vectors embeddings which capture the semantic meaning. Super important for semantic search and, crucially, for RAG.
RAG, Retrieval-Augmented Generation. Right.
Exactly. And these embedding models have two main jobs. Embed documents for when you're storing your knowledge base, and embed query for when a user asks a question so you can find similar stored documents. Next up, prompts. These are absolutely vital. They're the instructions you give the LLM, how you guide its behavior. For chat models, you'll mostly use chat prompt template. This lets you build structured, multi-part prompts. You can define different roles like system instructions, you are a helpful assistant, the user's input, and even previous AI responses.
So you can shape the conversation structure.
Precisely. And a key piece inside these templates is often messages placeholder. This is how you dynamically inject changing content, like the conversation history or the documents retrieved by R, right into the prompt before sending it to the LLM. It ensures the model has all the context it needs. Okay, then we have indexes and retrievers. This is really the heart of R. This is how you ground the LLM in your own external private data. Stop it from making stuff up and make sure it's factually accurate based on your sources.
Super important. How does that work?
It starts with document loaders. They ingest data from all sorts of places, web pages, PDFs, Notion, databases, whatever, into standard document objects. Then, because documents are often too big for an LLM's context window, you use text splitters. Something like recursive character text splitter is common. It breaks large docs into smaller, semantically meaningful chunks.
Okay, chunking.
Right. These chunks then get turned into embeddings using an embedding model, and they're stored in vector stores. Think of these like specialized databases like Chroma or Pinecone or Faithase, designed for super fast similarity search on those vector embeddings. And finally, retrievers are the components that actually fetch the relevant chunks from the vector store based on the user's query. Usually you just call .asRetriever on your vector store. This makes sure the LLM only sees the most relevant bits of information for the current question. Now, for any app where you need back and forth conversation, memory is key. And like we touched on, the modern recommended way is using LangGraph's checkpointing feature. You'd use something like a memory saver. This gives you a really robust, durable way to persist the conversation history. It automatically saves the state after each interaction.
So that ties back to LangGraph again.
Exactly. It's a huge improvement over older, manual memory management techniques, which honestly were often error-prone and could easily lose state. And then finally, output parsers. The LLM usually gives you back raw text, right? Output parsers take that raw string and structure it into a format you can actually use downstream in your application. Could be simple, like Stroutput parser just for the string, or maybe you need structured JSON, so you'd use JSON output parser. Very useful.
Okay, wow. It really sounds like LangChain has thought through that whole pipeline. Standard interfaces for everything from getting data in to getting structured data out. So yeah, these aren't just separate tools thrown together. They're clearly designed to interlock and make orchestrating these complex flows much simpler. And we've kind of taken the machine apart. But the real magic happens when you weave these components together into a working application, yeah? Let's walk through how you'd actually build something useful, like a conversational or RAG chatbot. Moving from just raw data to a fully stateful agent. You mentioned 3 phases.
That's right. 3 distinct phases. First is the indexing pipeline. Think of this as a one-time, usually offline process to prepare your knowledge base. You don't run this every time a user asks a question.
Okay, pre-processing.
Exactly. You start by loading data. Maybe use web-based loader to grab content from, say, the LangChain documentation web pages. It puts it into document objects. You can even use things like SoupStrainer to be more efficient. Maybe only grab the main content div from the HTML, ignore headers and footers. After loading, you split documents. We often use recursive character text splitter for this. Break those potentially long documents into smaller, manageable chunks. Why? Well, you need chunks small enough to fit into the LLM's context window along with the prompt in question. And smaller chunks are often better for retrieval accuracy.
Makes sense. Are there typical sizes?
Yeah, you might set parameters like chunk size 1,000 characters, maybe with chunk overlap 200. That overlap is important. It helps ensure you don't accidentally cut off important context right in the middle of a sentence between chunks. You want semantic continuity.
Gotcha. Overlap prevents losing info at the seams.
Precisely. Then you embed and store these chunks. You take an embedding model, maybe OpenAI embeddings or a local one, convert each chunk text into a vector embedding. And you store these embeddings, along with the original text, in a persistent vector store, like Chroma. Persistent means you save it to disk so you can just load it next time, rather than re-indexing everything. Okay, phase 2 is the actual ag chain. This part is initially stateless. It's the core logic for answering a single question based on your index data. First step here is loading that persistent vector store you created in phase 1.
So you don't re-index.
Right. Then you create the retriever from that loaded vector store. You might configure it, say, to fetch the top 4 most similar chunks using search augs, clo. Next, and this is absolutely critical, you define your RAG chat prompt template. This prompt needs to be very precise. It typically instructs the LLM to synthesize an answer only based on the retrieved context provided and not use its general knowledge.
To prevent hallucinations.
Exactly. You might even add constraints like keep the answer to 3 sentences maximum to keep responses focused and concise.
Good tip.
Then you compose the chain itself declaratively using LCEL. You might use components like runnable pass-through to pass the original question along, and runnable parallel to run the retriever and pass the question simultaneously. This orchestrates the flow. The question goes to the retriever fetches context, and then both the original question and the context are formatted into the prompt for the LLM.
Okay, that's the LCEL magic connecting the pieces.
Right. And if you invoke this chain with a question, it'll use the retriever, use the prompt, call the LLM, and give you a good context-grounded answer.
That's why even if that first answer is brilliant, if I ask a follow-up like, what about that pipe operator you mentioned? It just fails, right? Because it has no memory. It's starting fresh every single time.
Exactly. It's stateless. Each invocation is totally independent. That's obviously a massive hurdle for any real chatbot. Nobody wants to repeat themselves constantly.
Right. That wouldn't work.
And that's precisely where LangGraph shines, bringing us to phase 3, the conversational agent with LangGraph. This is how we enable true, stateful, multi-term conversations. First, you define the agent's state. Usually this is done with a Python typedict. The really crucial part here is how you define the messages field in that state. You use annotated list, operator.add.
Annotator.operator.add, what's that do?
That's a key instruction for LangGraph. It tells it, for this messages field, don't just replace the value each time. Append the new messages to the existing list. This is fundamental for building up the conversation history turn by turn. Okay, then you define a node function. Let's call it call_RAGChain. This function will typically take the current state as input, invoke your stateless arg chain from phase 2, get the response, and then update the state, usually by adding the user's message and the AI's response to that messages list.
So the node runs the core logic and updates the history.
Exactly. After defining your node, you wire up the state graph, you define an entry point, connect it to your call rag chain node, and then connect that node to the special END state, meaning the turn is finished. But the crucial step for conversation is adding memory. You compile the graph using a checkpointer, like memory saver.
With checkpointing again.
Yes. This checkpointer automatically handles saving and loading the entire agent state, including that growing list of messages. It usually ties the state to a unique identifier, like a threaded or conversationed. So now, when you interact with the compiled graph using a specific threaded, LangGraph loads the previous state for that thread, runs your node, gets a new state, and the checkpointer saves it again. This allows the agent to correctly answer follow-up questions because the entire conversation history is persisted and available in the state for the prompt. LangGraph is absolutely the production-ready paradigm for robust memory and complex LLM apps.
That is the difference right there between a cool one-shot demo and an actually usable conversational product. That state management is key. But okay, building a working prototype, even a stateful one, that's just step one, right?
Yeah.
To really take your LLM application into production, you absolutely need to focus on the full MLOps lifecycle. Observing, debugging, evaluating, deploying. How does LangChain help there?
Yeah, absolutely critical. For observability and debugging, LangSmith is, again, just invaluable. LLM interactions can feel like a black box sometimes. LangSmith makes them transparent and debuggable.
Dang.
Well, it's surprisingly easy to set up. You just set a few environment variables, and basically all your LangChain runs every chain invocation, every agent step get automatically logged to LangSmith. Then you get this amazing hierarchical trace analysis. You can literally drill down into every single step of a complex run. You can see the exact query that went to your retriever. You can inspect which specific documents it retrieved. You can see the full formatted prompt that was actually sent to the LLM.
Ah, so no more guessing why the LLM gave a weird answer. You can see exactly what context it got, what instruction.
Precisely. It's invaluable for pinpointing issues. Maybe your retriever pulled irrelevant junk. Maybe your prompt formatting was messed up. LangSmith shows you.
That alone sounds like it would save days of debugging, seeing the internal monologue, essentially.
Totally. And LangSmith also has this neat playground feature. You can take a recorded trace, tweak parts of it, maybe edit the prompt or change the model settings, and then rerun just that step or the rest of the chain from that point. Super tight feedback loop for debugging and iterating.
Nice.
Then there's evaluating our RCAP performance. You can't improve what you can't measure, right? Rigorous, metric-driven evaluation is essential. It helps you quantify performance, catch regressions when you make changes, and objectively compare different versions of your prompt, retriever, or model.
Okay, so how do you evaluate?
Typically, you create a test dataset. Questions paired with known ground truth answers or reference contexts. And increasingly, people use LLM as a judge evaluators. You basically use another powerful LLM to automatically score the quality of your RA system's outputs against the ground truth. It's incredibly efficient, especially at scale. And you look at specific metrics. For the retriever, you care about context precision of the documents retrieved, how many were actually relevant. High precision means less noise distracting the LLM.
Okay, relevance.
And context recall of all the possible relevant documents in your whole data set, how many did the retriever actually find? Higher recall means more complete answers.
Makes sense. Precision and recall for the retriever.
Then for the generation part, faithfulness is key. Does the LLM's answers strictly stick to the information given in the retrieved context? Crucial for avoiding hallucinations. And finally, an end-to-end metric like answer correctness. How semantically similar is the generated answer to the ground truth answer? Does it capture the right facts? This gives you an overall quality score.
That's a really comprehensive suite of metrics just for RX. Okay, observability, evaluation, and finally getting it out there. Deployment.
Right, finally, deploying with LangServe. This piece really streamlines turning your LangChain runnable, whether it's a simple chain or a complex LangGraph agent, into a production-ready REST API. You basically create a simple server.py. You import your chain or graph, import FastAPI and add routes from LangServe, and use add routes to expose your LangChain app at a specific URL path.
So just a few lines of Python.
Pretty much. Then you run that server file using an ASGI server like Uvicorn. LangServe automatically creates standard API endpoints for you. Things like invoke for single inputs, batch for multiple inputs in parallel, and even stream if your chain supports streaming output. This instantly exposes your powerful agent as a scalable, industry-standard API that any other service or front-end can easily call.
Okay, so LangChain really does cover that whole life cycle. Build, observe, evaluate, deploy. Very comprehensive. Now, we've focused heavily on conversational R, which is obviously a massive use case, but LangChain allows for even more sophisticated stuff, right? Like building agents that can actually reason and choose actions dynamically. Let's touch on that briefly, maybe with custom tools.
Yeah, that's a key distinction.
Correct.
We've mostly talked about chains, which follow a predetermined sequence of steps. Agents, on the other hand, use the LLM itself as a reasoning engine. You give the agent a goal and a set of available tools, and the LLM decides which tool to use, in what order to achieve the goal. It observes the outcome of using a tool and decides the next step. Much more dynamic.
Okay, so the LMM is driving the process.
Exactly. And here's where it gets really powerful for tailoring things to your specific needs. Custom tools. LangChain makes it incredibly easy to create your own tools using a simple Python decorator at tool. You just write a regular Python function that does something useful, maybe queries your internal database, calls a specific company API, performs a complex calculation. You decorate it with @tool, add a good doc string explaining what the function does, what inputs it needs, and what it returns.
And the agent can figure out how to use it just from the description.
Pretty much. The agent's LLM uses that doc string to understand the tool's capability. So if a user asks something that requires, say, calculating 5, 7, and you've provided a custom multiply tool with a clear description, the agent can figure out it needs to call your tool with the inputs 5 and 7 to get the answer. It's a straightforward way to give agents access to proprietary data, internal systems, or any capability beyond standard web search or basic knowledge.
What an incredible journey we've taken today. Really, from understanding those foundational challenges of just working with LLMs to navigating LangChain's whole ecosystem, building out a pretty sophisticated R edge, and then actually getting it ready for prime time with evaluation and deployment. I think the core takeaway really throughout all this is that LangChain provides that essential scaffolding, right? It handles the complex orchestration models, data estate tools, freeing you, the developer, up to focus on the unique, valuable logic of your specific application instead of getting totally bogged down in the plumbing.
Absolutely. And to tie this to the bigger picture, the skills we've walked through today.
Yeah.
Understanding that our cape line, implementing stateful conversations with LangGraph, doing proper evaluation with LangSmith, deploying with LangServe. These are genuinely the fundamental building blocks for anyone serious about applied AI engineering right now. If you can master these concepts, you're really well equipped to build the next generation of intelligence systems.
So as you, our listener, continue your journey, here's maybe a final thought for you to mull over. Challenge yourself. Explore that huge ecosystem of integrations LangChain offers. There are hundreds. Maybe dive deeper into more complex agentic workflows. Can you get an LLM to reliably perform multi-step tasks using several tools in sequence? Maybe interacting with external APIs or databases. And don't just stop at basic retrieval for RG. Look into advanced retrieval strategies, re-ranking, query transformations, hybrid search. Make your RGE systems even smarter, even more precise. Because really, the next generation of truly intelligent applications, it's waiting for you to build it.